Good morning. Today we're going to be covering functions involving the number e, and they're going to be exponential growth and decay functions. It's going to be very similar to the lesson that we covered last time we met, which was exponential growth and decay. Now let's look at the actual definition of the number e. The natural base e, or the number e, it's an irrational number because, as you guys notice, it continues to repeat. The decimal continues, but it never repeats. The other irrational number that we know is pi, 3.1415926535, and it continues. So this is another irrational number that's that you guys will see often in math. For this class, you can just memorize that e is approximately 2.7. So we're just going to round that up to one decimal place. Now, on example number 1, we're going to be dealing with e as if it was a variable. We just need to simplify. We don't need to evaluate. The difference between simplifying and evaluating is that simplifying, your answer will be with an e, which is 2.7. Here, we're actually going to substitute 2.7 for the letter e. So for letter A, we're going to add the exponents. So 5 plus 2 is 7. So e to the 7. And that's it. We just simplify. For letter B, you can think about multiplying the 3 times each one. The exponent for the 3 is a 1. Now, you can expand it 3 times just like we've seen before, or we can just multiply the exponents. 3 times 1 is 3, so 3 to the third power. 2 times 3 is 6. So that will give me 27e to the 6. For letter C, we are going to reduce our fraction. So 9 and 27, 1 over 3. Now, when we have a negative exponent, we're going to bring it to the denominator. So we have 7 e's, and 2 more is a total of 9. And that's it. For letter D, remember that this is a cube. So I need to find the cube of 54. One way of doing this is by finding the factors, the prime factors of 54. So do your 3. 9 will be 3 and 3. 6 will be 2 times 3. We can think about taking groups of 3. So how many groups of 3 do I have? I can take out this group of 3. That will stay outside. Inside the radical will be a 2. Now think about how many e's are inside. So we have 7 e's inside. How many groups of 3's can I take out? 2. Very similar to the lesson for 6.2. So I can take out 2 groups of 3. And how many e's are left inside? 1. Now for example number 2, I need to be able to evaluate the following natural base. This is where you have to substitute the value of e. So we have 2, but instead the e will be 2.7. Multiply 2 times 2.7. 2 times 7 is 14. Carry 1. 2 times 2 is 4, and 1 is 5. And 1 decimal place. Whenever you evaluate, you need to be able to give me a number. No variables when you evaluate. For letter B, before we actually substitute the value of 2.7 for the e, we notice that there's a negative exponent, so we need to simplify first. We're going to bring it to the denominator. The 2 stays outside. Inside, the 2 stays on top. On the bottom will be e squared. I'm going to replace the value of e now with 2.7. So it'll be 2.7 squared. 2.7 squared is 2.7 times 2.7, and we're going to be doing that on the left hand side. 2.7 times 2.7, that's 49, carry 4, 14 and 4 is 18. That's 14, carry 1, 4, that's 5, 9, 2, and that's 7. 2 decimal places. So that will give me 2 over 7.29. Now we need to divide the 2 inside, outside, we have a 7.29. As you guys remember, we cannot have a decimal outside, so we're going to move it twice inside, and I'm going to add 2 zeros. And now we can divide. How many times does 729 go into 200? 0. And we're going to add 0, so place a decimal. How many times does 729 go into 2000? Twice. 2 times 9 is 18, carry 1. 4 and 1 is 5, 14. Subtract, that'll be 542. Add 0. 729 going to 5420. 7 times 7 is 49. 7 times 8 is 56, which is too big, so it'll be 7. 7 times 9 is 63. Carry 6. 7 times 2 is 14 and 6 is 20. Carry 2. 7 times 7 is 49 and 2 is 51. Subtract, I will give you 317. 2 decimal places should be sufficient. Now I know it seems like a long process. Remember, you cannot use a calculator in the class, so you'll have to do it by hand. And the last one, let's evaluate. So it gives me 3. Instead, the E will be 2.7. 2.7 squared, we're going to do on the left hand side. 2.7 times 2.7, it's actually right over here. That's 7.29. So 3 times 7.29 multiplied by 3. 3 times 9 is 27, carry 2. 6 and 2 is 8, and 21. Remember, evaluating, you must give me a whole number. Now, let's look at the graphs of natural base function. It's going to be an exponential growth or decay, just like we've seen before. Now, the only difference is that if it's positive, that if the exponent is positive, that's going to be an exponential growth. If the exponent is negative, it's going to be an exponential decay. If it has a number, if it has a negative on the front, if the a value is negative, the only thing that happens is flips. If the a value is negative, so instead of 3e to the negative x, it's negative 3, it flips. We still have the asymptote, which we covered before. Remember, the line is getting closer and closer to the asymptote, but it's never touching it. So let's go and work out the problems on the backside. We have the following form of an exponential function with base e. We still have an h and a k. If you guys notice, h is a negative h, so it means the opposite of h. We basically going to sketch the basic part of the graph, and then we're going to use the h and the k to shift it. Example number 3. First, let's decide, is this going to be an exponential growth or an exponential decay? If we look at the graphs on the back side, the only way to figure out if it's an exponential growth or decay, we gotta look at the exponents. If you notice, this is a positive exponent, so that'll be an exponential growth. Your graph will look something like this. Let's go and make a sketch on the left hand side so we remember what the graph needs to be once we finish. Now let's go and graph part of it. Part of the graph, we're going to start by leaving the h and the k out of it. Y is equal to 2e to the x power. We are going to find different points. So let's go and let x equal to 0. So I can find the first point and plot it. This will be y is equal to 2e, but instead of the x will be a 0. Y is equal to e to the 0 is 1. Anything to the 0 power is 1. So even e to the 0 is 1. 2 times 1 is 2. We're not going to be doing domain and range yet. We're going to save it for the next chapter. So if the x value is 0, the y value is 2. That's my first point. For the second point, we're going to let x is equal to 1, and we're going to plug in a 1 into the basic part of the graph. Y is equal to 2e, but instead of the x will be a 1. Y is equal to e to the 1 is just e, which is 2.7. 2 times 2.7 will be 5.4. Therefore, if the value of x is 1, the corresponding y value is 5.4. So 1 and then 2 for 5.4. Now, ideally, you want to be able to sketch your graph now and say, okay, this is the sketch. It's an exponential growth. Here's my asymptote. Then you will want to use your shift, your h and your k, which is -2 and -3. Don't draw this yet. And say, okay, this is -2, so I'm going to shift it to the left 2. This is -3, then we'll shift it down 3. So once you have a graph, then you want to shift it 1, 2, and then down 3. 1, 2, 3. And then graph it. But without having a little overhead, it's really difficult to do it, even to transfer it. So that's why we actually have to do step by step. We have to shift each of the points. I'm going to shift it to the left 2 and down 3. To the left 2 and down 3. Left 2, down 3. Remember that your asymptote will always match your k value. Your -3 in this case. That is y is equal to -3. And then erase your previous points. You no longer need these points. Those were just a base to graph. And this is going to be exponential growth. Remember, it should look something like this as exponential growth. Coming here, and it's growing very quickly. You can just have it this side. Remember, on the left-hand side, it's getting closer and closer to the asymptote, but it's never touching it.